Have you ever wondered when you have this, when you find this new library that is a native iOS or Android, and you want to write bindings for it? All right, well, check it out. On the main stage, we're going to have Jonathan Dick, no less. He's going to be talking to us about how to bridge the gap with bindings to native iOS and Android SDKs. So go check it out. Even if you have already developed some bindings before, I am sure you're going to learn some tricks from his session.
All righty, here we go. Can you guys hear me all? We're good to go. Great to be here. Let me just get my screen sharing going. And let's select the whole screen. Let's watch all of that. Okie dokie. Sorry, getting in here. And of course, it's wanting me to approve something here. So let me just do that quick. Oh, no. Let's try that. All right, I think we're good to go. Let's close this up. Let's start off the presentation. So first of all, thank you for having me out. It's good to be back. It's been a while since I've done conference talks, and I used to do it a little bit more, and it's great to have the opportunity to be able to do it from home now, I guess, too. So a little bit about myself. My name is Jonathan, and I have been with Xamarin for quite some time now. I was actually thinking it was kind of funny that I was years ago at a conference that I was on the same time slot as another forms talk, and it feels like I'm always talking about bindings for some reason, and that's just what I always end up doing. So it's even more funny now because actually I am recently the engineering lead on the xamarin.forms project. So if you go follow me on Twitter, keep you up to date with what we're doing with forms and Maui, and of course David, my good friend, is talking about Maui at the same time too. So all good, catch all the sessions, and I'm really glad to be here. All right, so today we are talking about bridging the gap with native bindings, with native libraries. Now, if you've done bindings before, like you said, we'll maybe get to learn some new tricks here. I've got a new kind of pattern or technique that I want to share with you and do a demo of. First, though, I think we'll just do a little bit about talking through what bindings are themselves. And then I want to show you just at a high-level overview, if you're not familiar with bindings, what this kind of looks like, what the process is for iOS and Android. And as I mentioned at the end, I'd love to do a demo of this new concept or new pattern I'm calling slim bindings. Well, I mean, that's not fair. It's not entirely new, but I'm really trying to kind of push the idea forward and see if we can improve the process around that to make it a really nice way to consume native libraries. So first of all, what are bindings if you're not familiar with them? Well, when we want to call native SDKs, we want to do it from C# because, I mean, that's why we're all here doing Xamarin, right? We like C#. So you can kind of think of bindings as just a way to bridge the .NET runtime with the native SDKs. And in fact, if you really think about it, Xamarin itself is really just a bunch of bindings. We do the hard work of maintaining those bindings to all of the core frameworks and SDKs and libraries and everything. But at the end of the day, we use a lot of the same techniques that you would use to create bindings to your own libraries. So the nice thing is, more and more it seems like we're seeing customers don't really need to do this as often as maybe we would have in the past. I can recall, back in the day when somebody came up with the concept of like the pull to refresh, table view thing. And so there was a library out to do that. And of course, we created bindings for it so that you could use it from Xamarin. Well, more and more stuff is baked into just the core platforms and then just into Xamarin and xamarin.forms and all of this great stuff that you don't often need to do it. But sometimes you still do want to be able to bring in some SDK. Maybe you have some specialized thing that you need that nobody else really uses or isn't that common and there's no binding for it. So you can have it all, right? You can have the best of both worlds. So let's talk a little bit about the different types of different platforms and different types of bindings and the processes around them. So for iOS, generally, libraries have been written historically in Objective-C. We're starting to see more and more libraries now written in Swift, of course, and that's Apple's kind of new direction of bringing the new language in. And these both require different approaches to how you bind the libraries. So for Objective-C, the process kind of looks something like this. You've got your native library. This is probably like a .a file, or used to be more so. Now you'll see more and more .frameworks. And you'll also see some XC frameworks that are kind of a newer thing that we're still working on fully supporting. But at the end of the day, these things all have these native code compiled into a library, a binary. You could get these things on CocoaPods often. There's another sort of service called Cartage. These are kind of like NuGet for Objective-C or Swift developers. And often these will have precompiled binaries for you. And these binaries, they're native code, so they're compiled for a particular architecture. But now Apple has a way that you can create what we call these fat bindings, which have multiple architectures into one single binding. So the first step is to get the thing that you want to actually bind. Once you've got that, you've got to do a little bit of work with Objective-C to make it actually work to generate a binding. So we have what we call this API definition, and it's sort of like a pseudo C# language. I mean, it's C#, but it's not quite just normal .NET C#. And the idea of this API definition is to describe the Objective-C API, and we then turn that into actual binding code, glue code, p-invokes, all the fun stuff for you so that you can actually call it from C#. Now, I like to think of this approach as sort of an additive approach because you start with kind of nothing and you tell us, okay, what are the things from that native library that you actually do want to bind? And we have a tool to help with this called Objective Sharpie, and we'll take a look at these in more detail in just a little bit. But the end result is that you get C# that you can call from your Xamarin apps. It's a bunch of generated code, and it handles all of the communication into the native SDK for you. Now, I talked a little bit about the native library already. Some of these frameworks often contain like these actual libraries, or they do contain these libraries. They're often already these fat binaries for you, and you can go use the lipo command line tool on Mac to use the info command to check that, and it'll list out what architectures are actually in that binary. If you don't have one of those, and what we'll see today is we're going to create our own library in Xcode. This is kind of something that isn't that obvious, and maybe you won't see in a lot of places, so I thought it was interesting to kind of leave it here for you. To create that binary, you can just use the command line tools that are on your system. So you need to build Xcode, the Xcode project for the different architectures that you want to combine. So here we're building it for iPhone OS with the ARM64 architecture, and then we'll do the same thing, build it again for iPhone Simulator for the x86 64 architecture. And so the reason we have these two, of course, is so that your library can work in the simulator, but also on the iPhone device itself, right? And you can combine these architectures by using the lipo tool again with a different command, create, and you specify, where do you want the output to be and what do you all want to combine. And if you were to check that again after with the info, you would see, oh, great, it's got all of the architectures now in it. So this is something that we need to do if we're creating our own Xcode library, and we want to bind that as well. Now, I mentioned Objective Sharpie. It's a tool you can go grab. There's the install link. Also, go check out our docs. They're actually really quite good for doing bindings for both iOS and Android. So here's the link to how to use Objective Sharpie, and that'll kind of land you in the docs section for all of the binding topics. And the command line tool works kind of something like this. Sharpie bind, we tell it the framework. In this case today, we're going to make our own framework called the Mapbox wrapper. And then the SDK that you want to bind against so that it kind of knows where to find the UI kit frameworks, all like the built-in ones that might be referenced from the thing that you're binding. And finally, at the end of this, you get this API definition generated and this structs file generated, and we'll look more at those too. Here's the API definition. I don't want to spend a lot of time here because this is part of the thing that this new pattern I'm trying to help us avoid. This is where a lot of the hard work actually goes into. And you can imagine on a really big complex API, there's a lot of code that's going to come in here. And now the thing with Objective Sharpie is that it doesn't always get it perfect either. And that's really because header files in these libraries, that's what we use with Objective Sharpie to parse. We parse those things out, and we try and kind of make sense of like, okay, what is this actual API? And so we give it our best shot, and Objective Sharpie does a pretty good job, but there's still some manual intervention that has to happen. So in this case, you see, you've got a protocol, which is kind of like an interface in C#. And we are able to parse out or describe, there's a say method, there's a listen method. We marked one of them as abstract. So if you're implementing this, you're going to have to actually implement that method. And then we've got an interface, which is another class here for the My tool, which has a method or a property to go ahead and get the actual protocol that you just saw before this. Now, again, I don't want to spend a ton of time on this. There's documentation on how to do it, good examples. We're going to try and avoid this. All right, so we have all the bits and pieces. This is how they kind of all fit together. Our API definition, our structs file, any extras you want to put in, you can do that too. You can add like your own static extension methods and stuff to types that will get generated. It's kind of cool. We feed those into this binding generator tool that happens at build time. And we combine that with the actual native libraries to output this binding DLL. And this is the .NET assembly that you're going to actually reference and let you actually access those APIs. All right, so I talked about Objective-C. Well, there's Swift libraries and this as well, and this gets a little bit more sort of tricky these days. So, I mean, same thing. You start with a native library, kind of get at the same places, but in this case, the binding work, well, we can kind of do in one of two ways. Now, the preferred way is something that's still heavily being worked on. Steve on the iOS team is doing a great job at bringing what we're calling binding tools for Swift into existence and being able to take a Swift library. Now, because Swift libraries have a lot more metadata in them and a lot more like well-structured metadata in them, we can actually use them to do a lot better of a job at automatically creating bindings for you. The difficulty and the challenge is that Swift itself as a language has a lot of different sort of language paradigms that don't necessarily map really well to C# and are actually really quite very difficult to map into C#. So this is something that we've been working on for a while. It's certainly capable of binding a lot of different APIs already. I'm not going to use it today. Just I know Steve's wrapping up some work on getting it compatible with the latest version of Xcode because the cheese keeps being moved on us by Apple. But pretty soon this should be a tool that you can use to actually do some of these bindings that we're going to talk about today. Now, if you encounter a Swift library that doesn't, or that it's a Swift library, it's not Objective-C. One of the cool things is a lot of library authors are still outputting Objective-C headers for their libraries, so that you could still bind them with Objective Sharpie, and that's kind of what we're going to do today. I'll show you that in a bit. And finally, the end result is kind of the same. We generate a bunch of C# code for you, and then you can invoke into that library, and you're good to go. All right, we're going to move along because we got lots to cover. Android bindings. So Android is similar but different. I mean, we start with a native library again. In this case, it's an AAR or a jar file. We get these from Maven, which is kind of like Android's analog to NuGet. And once you have those binaries, the binding work looks a little bit different. Now, I mentioned Objective-C was sort of like an additive approach. I kind of view this one as more of a subtractive approach. So what we actually do is we parse those native libraries, and kind of like with Swift, there's more metadata available, so we can make a better kind of representation of what the actual API looks like. And so we do that, and then we dump that out to some XML files, at which point you have the chance to alter them. And so because we kind of try and give you the whole picture, I kind of call it subtractive because you can do things like remove bits that you don't really need or don't really want, or maybe they're causing you problems. And the way we do that is with XPath transforms, basically. And you'll see an example in a second. And again, like Java doesn't always map perfectly to C#. So this is where we kind of run into situations where it's really hard actually to automate the process entirely for really complex APIs. Something like covariant return types isn't really a thing in C#, or not yet anyway. I think it's coming actually. So again, end result, get a generated file, C#, it's a big file with a bunch of different calls that actually do the actual JNI invocations and everything for you. And it's just a lot easier than writing that code by hand. All right, so native libraries on Android, we have Rs, we have jars, and the Rs are just really stuff with extra stuff in them. They're jar files, they're resources, they're manifests, they're ProGuard configs. It's kind of like a newer format, almost like a NuGet package. And again, docs, we have docs. Go read the docs. They're quite good. They help solve a lot of different problems that you might run into. And Maven, as I said, is kind of like NuGet. There's a bunch of different Maven repositories that you might look for dependencies in. And talking about dependencies, well, that's really the tricky part here. With iOS, it's interesting because it just doesn't seem like a lot of iOS like library authors use a lot of dependencies in their libraries. So you don't often see complex dependency graphs on iOS. On Android, it's quite the opposite. The dependency trees are often very large and deep and complex. And so half of the challenge in binding Android libraries is sometimes just figuring out that dependency graph. So I want to show you a couple of strategies, including a Gradle plugin that I've been working on. And that just kind of makes the whole process a bit easier. So for Android, this is kind of what the flow looks like. So we get that binary class file parser, and class files are what are inside of jar files that describe that are the actual code implementation. We produce this generated api.xml file, and you can actually go in the Obj folder, like your intermediate output path, and you can see this file. And it's just this big XML file that's a representation of an API. And once we've got that file, this is where you start to write your own XML files that will transform what's in that original generated file. After that transformation happens, we've got our final API XML file, and then our code generator uses that to emit all of the binding glue code and all of the yucky stuff that you don't want to have to write into an actual .NET assembly that we can reference. So here's kind of what the generated API XML file looks like. And so you can see things like the API is the root element. We've got a package element with a name. So that's like a Java package, right? It's like a namespace. We got the class, we have the name of the class, and then we've got its visibility and JNI signatures and stuff that we need to know for how to generate the bindings. We've got methods inside of it and parameters for those. And so that's this hierarchy, this XML representation of an API, which is pretty good. Now, when it comes to actually transforming that, we can do a bunch of different things. And this is where, the bindings kind of get a little bit more tricky. Now, we can do simple things like this. This is an example here of the first line is this attribute element, this attr element, and it's got a path attribute. And that path attribute is where you specify your XPath query. And so you can see, if you're at all familiar with XPath, you can look, we're looking for, a package node under the root API node. And that package node needs to have an attribute of a name, which equals com Microsoft device display. So this is an example from some of the binding we did for the Surface Duo SDK. And now you've got the name attribute, and that value in that name attribute is managed name. And so that name value is an action, and there's a bunch of predefined ones that we can use. In this case, it's saying, okay, I know the Java name for this is for this package is com Microsoft device display. I want to change it in C# so I don't have an ugly namespace like that, because it's not really .NET-y. I want to change it to Microsoft device.display instead. And so that's what that action does. There's a bunch of other different types of actions we can choose. And this one below, we're changing the property name, or rather we're saying don't use a property name because I actually want a method, not a property. So by default, the generator tries to do some things that make your code a little bit more .NET friendly. In this case, we're telling it, don't do those tricks. We want it the way we want it. So the attribute element is for changing things, right? Here's kind of the format. You've got the query, like I said, and the actual attribute. And here's a bunch of the possible different attributes that we can do. We can change the managed return type. That's often a way that we kind of use to get around the lack of C# support for covariant return types. We did the property name. We can change visibility. There's a bunch of different stuff we can do. There's also a remove node, and you can imagine what that does. That's actually quite useful. So often in Java, we might see like an internal package name somewhere. And even though it's marked as that, there would be public types inside of that we don't actually really want to bind because they're not meant to be used by us. So we might just decide to remove a whole package by the name if we want. So that thing, whatever that query matches, that XPath query, it'll remove that thing and any children underneath it. So that's really useful. In the same sense, we have this add node, which we can say, okay, maybe in this class, I want to add another method. And so I would use my XPath query to query the class that I want to select. And then I would add the code I want injected into that element from this add node inner elements here. We don't often use that one so much. Usually it's more about remove nodes and sort of changing existing values. I should mention there's a couple other files that deal with enums. They're really quite optional. They're just kind of a nice way to make a really pretty C# API, that instead of using constant integers from Java, which is what they do, it'll turn them into proper C# enums. And so you can figure out how to use that from the documentation as well. All right, so that's a very high over level of bindings and kind of how they work and how the flow works. I encourage you to go check out the documentation. But one of the things I promised is that I want to not spend a lot of time in the actual code for tweaking those bindings and making them. I don't want to sit writing API definitions or transform files. So, I've really been looking at this approach that I'm calling the slim binding approach. And the idea is quite simple. So first of all, I mentioned before that if you get a really complex API with a lot of different complex like inheritance hierarchies and different, just tons of classes, tons of methods, generics in Java can be a kind of a pain to implement. If you have one of those, they can be really hard to bind because at the end of the day, as good as our binding tooling might be, it's really hard to kind of figure out all those scenarios, especially when you're doing it from a language that doesn't maybe map perfectly to C#. So on the other hand, those simple APIs, if you have a really simple, not a lot of like subclassing or things like that going on, those often are tools they kind of nail. They hit them out of the park. They can do them with no manual intervention pretty much. So the idea here is like, let's make a binding, a wrapper that our tooling can just handle. And then I don't have to spend any time in the API definition or in the transform files. Now, there's one other bonus to taking this approach, and we'll take a look, is a lot of the native SDK documentation, if you're working with some library, it's going to be for that native tool chain. It's going to be for Android Studio or for Xcode. And generally, it's easier to follow those guides with the native tools that they're meant for than to try and figure out, like, well, how does this translate into Xamarin? So how do we do some bindings? Well, like I said, it's a wrapper or an abstraction. And really the idea is like, let's just create this simple API. We're gonna, get out our Xcode and get out our Android Studio. We're gonna fumble a little bit with Swift and Java. I'm not a Swift or Java developer, but we're C# developers. We can probably figure out how to manage a really simple API, right? A couple hundred lines of code or something maybe. So that's the idea. And the other part of that is in that API, we don't want to leak any types out from the SDKs that we're trying to avoid binding. Otherwise, we would have to bind those types, right? So we want to use simple types like primitives, strings, numbers, whatever. We want to use things that we already know about in Xamarin, like UIKit, Foundation, Android X stuff, and we can do all that in our public API. So let's get into some code. That's enough talking about code. Let's actually look at some code. Now, I've done a lot of, creating some of the code to begin with because I don't want to spend time just writing code and seeing you watch me write code. But let's first take a look. We want to make an app that uses Mapbox. This is a very traditionally hard to bind dependency for Xamarin because there are just a ton of types, complex, hierarchy of inheritance and everything. And really, at the end of the day, a lot of people just want to use a little bit of these SDKs. And so this is a great candidate for this slim binding approach. So if I go to iOS, I can start looking at their install guide. And again, this is going to highlight their native tooling and how to do it with Xcode and not Xamarin. So, I kind of scroll down, install the maps, configure credentials, or it's like, hey, there's a direct download. Well, that sounds pretty good to me. So I decided to choose that. I went down to this part of the page and then I'm just following along instructions, right? Like go download this thing, drag these frameworks into your project, make sure these settings are correct. So let's kick over to Xcode. I've got a project already open here and let's just move this guy out of the way. I know I'm sharing my screen. I've got the Xcode project set up, and all I've really done is I went and made a new project, and I'll just kind of show you what that looks like. And you'll want to pick a framework project because that's the thing that we want to build so we can bind against. Give it a name. I chose Swift in this case because, hey, that looks a little bit more familiar to me than Objective-C at this point. I'm not going to make it now. I already have one. And then what I did is I dragged over my frameworks, right? I downloaded these frameworks from that direct download link. I moved them into my project. I went into the project settings and I followed the steps of what they told me to make sure they're here and how they're set. And then I added a Swift file. So let's open this up. This is our API. This is our simple wrapper API. Now, I mentioned before that Swift, you can export Objective-C headers. I think I mentioned that. If I didn't, you can export Objective-C headers. That means we can use Objective Sharpie to bind this library still, even though we wrote it in Swift. So that's kind of cool. So I've got a public class here called Mapbox Wrapper. You can see it subclasses NSObject, which again, Xamarin knows about. Then I've got some internal instances of MGL map view. So this is the Mapbox type. This is the thing I don't want to have to bind, because if I try to bind this, it's probably got methods and properties and all sorts of other things that use Mapbox types that I'm trying to avoid binding. But it's okay if I keep them privately. I just don't want to have to worry about them in C#. So I'm going to decorate everything that I want to bind with this annotation here. And I've got this public init method, which is like our constructor, and that's what we'll map it to in C#. It takes the cgrect to know how big to make the map view. Again, Xamarin knows about that. It takes also this Mapbox Wrapper callback. And this is defined down here. This is a protocol, which is like an interface in C#, right? And it defines just two simple methods. It defines a marker clicked and a map ready. And so this is going to allow the native side here of our wrapper to call back into the C# side when something happens. So there's this two-way bridge kind of going back and forth, right? If we go back up here to our init method, I really just copied and pasted most of this code from the tutorial. And that's kind of another, again, advantage is I don't really have to know a whole lot about how to write Swift. I can mostly just kind of copy and paste and change a few things here and there to do what I want. So after our map is all initialized, I've got my next function here, which is called getView. Now, here's where some of the magic works. Notice I'm returning UI view, and I'm not returning the actual, remember this was a MGL map view, right? Because ultimately, I know MGL map view subclasses somewhere down the chain from UI view. And Xamarin knows about UI view, so if I give it back a UI view, all I really care about is putting it in my view controller. I don't really want to call any methods directly on the MGL map view type. And at runtime, this will be an MGL map view. If you went and inspected that view at runtime, that's what it would be. But for me, the contract I care about is the one that's already bound in Xamarin. So that's kind of where the magic happens, right? I'm not leaking through any types that Xamarin doesn't know about. The next method, add marker, just passing in the coordinates to where I want the marker added, some a title and a snippet, and again, using the Mapbox APIs to add it to my view, but internally here and not leaking through these types. So that's it. I mean, like, the first time I wrote this, I hadn't honestly written anything serious in Swift. And I went ahead and I did this in, not that long of a time. I fumbled through the syntax a bit for sure, but it wasn't that horrible. Oh, and I forgot to mention, part of what we set up here is this map view delegate. Now you'll notice I didn't mark this public. This is because it is implementing the MGL map view delegate. Well, that's not a type, again, that I want to bind. So I don't want to expose this to my binding. Otherwise, it's going to cause me headaches. But I need this to get notified when the did finish loading happens of the map, or when the selection of the annotation or the marker happens. And so what I do here is I pass my wrapper into it when I make this, right? I'm instantiating it down here, and I'm saying, hey, here's the callback, the instance of the callback. And then I store this here for when Mapbox calls back to me. I can say, okay, callback, just call the map ready. The map's ready. Go ahead and do something with it. And when the marker's clicked, call that too and pass in the annotations title that was clicked. So a really easy way to kind of get that two-way communication going back and forth. Now we've got our wrapper written. That was it. That wasn't too painful. Now we can actually go in and build this thing. And I mentioned, some special things we have to do to build it. I could build it from here. And that would actually, I could generally like pick right now it's iPad. I could build for a device after and get the two outputs. But it's really easy just to do this from a bash script that I have. So I've got this open already. And I've got these commands to Xcode to build for the two different architectures, right? And ARM64 and x86-64 so that this will run on device or simulator. And then I'm using LiPo to create the FAT library. And that is going to combine, I'm doing a little bit of a trick here. I'm saying, oh, the output file is the one that already has ARM64 in it. And luckily, LiPo's smart enough to know just to like keep that, but then also add the additional one that I specify. And at the end of this all, I could go ahead and run LiPo info, and I could just kind of verify, yep, it's got all the architectures in it. Great, awesome. So that's all we have to do to build it. So I've done that. I've built it. We have our framework that's got both architectures in it. Now we need to bind it. So I've got another script here, and this looks just like what we looked at earlier in the talk. I'm using Objective Sharpie, and I call the bind, and I give it the framework we just built, and give it the SDK so it knows how to find everything. That will output in the folder I run this API definition file. So this looks familiar, right? We talked about this. Now, I mentioned Objective Sharpie does need some help after it outputs it. So there's a couple things. First of all, there's no namespace here. So I got to put things inside of a namespace. I'd have to put all of these types inside of a namespace. Second of all, there's a few of these verify attributes. This is going to cause compilation errors, and very intentionally, because it wants you to look at these and say, like, is this really what you want? Now, in this case, this is just binding some constants that are already there that I don't really care about. So I could just remove this whole thing. I don't need these, so I can remove that. The next thing down here is our Mapbox wrapper. Remember, we created that class, and the constructor, the init, took the frame and the callback. So this is all kind of set up for us binding. This all looks good. There's another verify down here for our get view, which it turned it into a property in C# for us. And it just wants to know, like, is that what you want, or do you want it a method? But I'm good with that, so we could just get rid of that. We've got our add marker thing, right? Which is great. This is what we used to actually add the marker. It kind of made the Objective-C-ish name, and that's okay. I'll just leave it. Whoops, scrolling too far. And then finally, we've got our callback interface, and it's, I mark these as abstracts, so we'll actually get an interface here, and we should be good to go if we change that all. All right. So when we have this file, we can go into our binding project in iOS. So I've already got this set up. Now, a couple things. I pasted this API definition in with all of the changes we just talked about, right? I got the namespace and removed that. I removed the verify. So we're good to go there, I think, right? We've got our API definition. The other thing that I did is I added native references to the frameworks, both the framework we created and the frameworks that we downloaded for Mapbox. And I did that with just, add a native reference, and then I browsed to the frameworks, added them in, good to go. So that's really all we have to it. The structs is just kind of empty because we didn't have any of those in our binding. So I could build this thing, and this is going to emit a binding for me now, which is great. And now I can go use that binding in my project file. Let me zoom in just a little bit on that for you. So in my actual app project here, I've got the reference to that binding project, right? And then I'm just going to go ahead and start using that code. So let me zoom out and let's look at this. So I've got a view controller. I'm implementing that callback interface. I've got an instance of the Mapbox wrapper that we have a binding for. I created a new instance of it here, passing in my frame and telling it, hey, this is the callback, because right, this class is implementing the callback. And then I add it to my view controller's view. Next, I implement this interface here, and I've got the marker clicked with title. So this is going to get called when I tap on the marker, and the Mapbox SDK calls back over to me, right? And I'm just going to display a UI alert and show like, hey, this happened. And then on the map ready, this is when I know Mapbox is ready to take, commands like adding a new marker. I just add a new marker here. So this is all pretty simple stuff, right? Not a lot of code here, but I get the functionality that I need out of the SDK through a really simple, slim bridge. All right, so let's fire this up. This one's nice and fast, so we'll fire it up. And, I could use some work maybe on this, but hey, look at this. This is my Mapbox. This is it. This is the binding to it. I just took this really complicated binding, and I can't scroll very well in it because I'm using a mouse, but here I am. Here I am in Canada, as far south in Canada as you can go. I always like to use this as a party trick to say, like, I live in Canada, but I live more southern than a bunch of the U.S. So I'm almost surrounded by the U.S. here. So anyway, this is Mapbox. This is our app. We're good. Let's talk about Android quick. Okay. So for Android, it's a little bit different. So for Android, part of the challenge is going and actually getting the artifacts, like I said, right? So if you go to the install page here for Mapbox, it's going to guide you through how to do this. How do you install it? Well, first you need to create, configure your credentials. Okay, well, I can follow that direction along. Configure your secret token. So I have to add this to this file that it says after I got my secret token. So I've already done that. I need to add the Mapbox token to my resources in my app. Okay. Permissions. Okay. And then we get down to the Maven stuff where we're basically saying it's kind of like a package reference, right? It's like, here's my NuGet package, go add it to my project, and it's going to go fetch all the dependencies and fetch everything for me. I can do that. That's easy. The other hard part here, or not hard, it's not that bad. I just have to copy and paste this custom repository. So you have to have credentials to download from their Maven repository. So you kind of have to add this in to the project level build Gradle file. So I can follow along. I can do all these things, but I don't know how to get the artifacts if I don't do it from Android Studio. There's not an easy way to do it. I think they used to have a direct download link, and I don't even see that on the page anymore. So I can follow along here. So let's go open Android Studio. Let's be brave. Now I made a new project in Android Studio already. They don't let you create a library project by default. So I have this app project. I'm just going to ignore it. After I did that, I went and made a new module within this project, and I made an Android library, and I just gave it the default my library name, and I created that. So that's where this came from. All right, so let's take a look at all of the parts of this. So we talked about that guide telling us to add stuff to the Gradle files. So there's the project level Gradle file, and that's where it told me to add this Maven repository, which I did, right? Copied and pasted. That's all I've done so far. Next, it told me to add some stuff to the module specific Gradle file. So I've done that. I've gone down to the bottom and I've added the dependencies that they asked me to add. Easy enough. I can do this. Then I can start coding my Java. So let's take a look quickly at what the actual wrapper looks like for the Java side of things. It's going to look really similar. I've got my Mapbox SDK, different class name, wasn't consistent there. And then I've got my instances of these Mapbox items that I'm keeping private. Now my public constructor here takes an activity for the context. It takes the Mapbox SDK callback, which is the same as we had in Swift, right? Map ready, marker clicked. And then it initializes it. I don't know if I need to do this, but I can actually pass the token in directly if I wanted to. And then Mapbox on Android is a bit different because it expects us to kind of proxy or relay on the lifecycle events to it so that it can know kind of how to manage itself. So I'm just kind of recreating the lifecycle events here as public APIs. I added a little flair here where I can pass in an initial longitude and latitude and zoom to kind of center the map on. So I start doing the code for Mapbox. And again, copy and pasting this from the tutorial mostly. Creating a new map view, right, with the activity, calling my map views on create because it wants me to do that. And then I want to get the map. And this, again, is kind of copy and pasted, right? And so they have a whole hierarchy of kind of adding callbacks. So I add a callback. Android Studio and IntelliSense here help me implement this. When the map is ready, I get an instance of this and my code's called. So I keep an instance of the map handy locally. And then I go, okay, let's set the style of the map. Let's do something a bit different. And when the style is finished setting, I'm going to go ahead and tell my callback listener that the map is finally ready. I also register some marker click listeners. I guess this is deprecated now, but it still works. And so when the marker's clicked, I also call my callback listener again, just like in Swift. And I've got my get view. And again, I'm returning this Mapbox view, but ultimately I'm just saying, let's just return it as an Android view because Xamarin already knows about this. That's fine. So I get that. I've got my add marker, and then I've got all of these sort of proxy events just to pass through to the map view, which I'll call from C#. So again, that's it. That's the wrapper. That's the code. Now, the tricky part of this is figuring out your dependencies. And so to do that, I mentioned there's a really complex dependency graph potentially. And so one of the tools we can use in Android Studio is to say, for my module, there's a Gradle command. There's called dependencies. So for my module, which is my library, call the dependencies task. And I'm only going to print out the stuff for the implementation configuration. Otherwise, I'm going to get a whole bunch of noise, and I don't want that. So if we call that, that's going to help show this big dependency tree here. Now look at this beast. This is the dependency graph that comes out of adding this one Maven artifact, right? So we've got more Mapbox packages. We've got OKHTTP. We've got Google JSON. We've got different other Mapbox packages, Android X. This is a lot of stuff to try and track down and figure out how to obtain these artifacts for yourself. So I've gone ahead and built a little Gradle plugin. So if we go back to the library Gradle, we can go actually look at this URL here that I've got in there. There's this Gradle plugin that I've got that's hosted on our GitHub. We'll put links after. And this is going to help you kind of make sense of these dependencies. So I apply this plugin right from this URL, and that gives me the ability now to call Gradle Xamarin. So what this is going to do for me is just help list things out for me at the very least. So, you know, I've got a little bit of an explanation like, hey, this is going to help you list out what things you need. A lot of times there's NuGet packages for some of these already. So maybe you want to go check those out and see if you can find them that match. And then a lot of, you know, for Android X example. And then I list out all of the actual Maven artifacts from that tree that you're going to need. So I've kind of like condensed that for you. So it's a nice flat list. So I know all these Android X packages have bindings for them already. So I can go add the NuGet packages for these to my project. I do know that there's a JSON one out there. It's called Google JSON. So a little bit of work, I could add this, or I can just add that artifact directly if I don't have any other dependencies that already use that NuGet package. And then all of these Mapbox ones, I don't know where to get these. So I'm going to need to get those. And then the Square ones, there's NuGets for these as well. It's also going to tell us, hey, where's the output of the actual thing project binding that we have? And that one's easier to find because it's in the same spot. But this is the actual AAR with our wrapper API that we want to bind. So that's good. So the other thing I kind of glossed over here that it does, you might have read, is it also copies the artifacts from this list to a folder that's easy to find for you. So by default, all of these things get dumped out to like some user profile directory that's some cached somewhere for Gradle. Not easy to track down. And like I said, I actually need to get a hold of these things to bring into my binding project. So if we look at the file system layout here, so I've got this is my project folder right here. And here's my module. And then we've had created for us after we ran that Gradle plugin, that Gradle task, a list of all the different files that we need. And so we don't need to pull the Android X ones because we'll ultimately use NuGet packages for those. But we would pull in, all of these AAR files and then these two jar files as well from Mapbox. And then I'll use NuGets for these two and for this one as well. So at the end of the day, it makes it really easy to track these things down and pull them in. All right, so we have our library built. We have our dependencies. We can go back to our binding here. And if we go back to our Android binding, let's just close this up. And let's look at the Android binding. We've got a few different things. Really, we've got this is that AAR file of the wrapper that we wrote. This is the one I want to bind. So this is set up as a build action of library project zip. And we can actually go now and make a binding for this. And you'll notice that I don't have anything in my transforms file because I don't need to, because it's a simple API and it can just work. It doesn't need help. So I've got that binding set up and I'll reference that into my project here. You can see my project reference. Now you'll see a few things here, right? So you'll see all of these AAR files. Now, if you're just directly referencing the binding project and you don't want to redistribute a NuGet or anything like that, that's fine. You can add these all to the app head. Now, it's a little tricky because in Xamarin right now, there's a limitation where you can only add a single AAR file to a binding project. You can add multiple jars, and we don't want to bind these, right? We just want them to kind of come along for the ride because we need them at runtime. So the easiest way to do this right now, unfortunately, is to add them to your actual application project. And I'll show you the source code for that quick in here. You can see all these Android AAR library items, and I've linked to all the AAR files. That'll just kind of tell the build system like, hey, here's this file, just include it for me in the app as you build, have it there at runtime, because my API, the wrapper I wrote, actually needs those files there at runtime. And then similar for the jar files, but it's just a different action. Now in .NET 6, if you watched Pepper's talk today, I'm not sure if he mentioned it much, but this is one of the things that he's improved going forward for .NET 6 as well. So this will be easier. You'll be able to add these all to like the one binding project or just everything to your app head. It's going to be great. All right, so we've added our artifacts, and then you might wonder where the other things went, like the Android X bits and the Google JSON and the Square OK HTTP. Well, they're all in here as NuGet packages that I found. So that's what we need to build that binding. So let's go back to the actual, that is the library project. We want to go, or the app project. We want to go in the main activity and see how we use this thing. And so We've got our main activity here. Again, you can see we implement the interface. That's great. We've got on our onCreate, we're just making a new instance of the Mapbox SDK. We init it. Again, I think this will just work if I had it in the resources properly, but I'm doing it anyway. Actually, I'm getting it from the resources. And then I've got the onCreate that I'm passing through, the initialization, like where we want the map to center. I implement the map ready again, and when I do that, I want to add the marker again, right? The map clicked, I'm going to show a toast that shows us that it was clicked. And then remember all these kind of like just pass-through methods that I just need to pass on from my activities lifecycle. So I've got those. That's great, looking good here. That's all there is to implementing it on this one. Now, I'm not going to wait for this one to build. I've actually still got the other thing running. I've got this already built and installed on my phone here, and so if we were to open this up and run it, we get our Mapbox map, right? And I think my Zoom cursor is crazy on this thing, but again, if I click this, I get my toast that tells us that the item was clicked, and I've got Mapbox in my app, and it didn't take that much code to do it, and it really didn't take that much native code to do it either. So this is how we do a slim binding. This is the slim binding approach. I mentioned this is a pattern that I'm really kind of liking and something that I've been spending some of my spare time on. I've actually got almost ready for maybe some kind of preview release, a NuGet package that you can add to your Android binding projects only for now. We'll do iOS in a bit yet too. And it's going to actually take care of, you can link your Android Studio project, and it's going to take care of invoking all the Gradle tasks for you and actually going and hunting down these artifacts for you, pulling them in as part of the build, and even going as far as looking for patterns in the artifacts and saying like, oh, I know about Android X. I know how to figure out, what those are on NuGet. And it'll go talk to NuGet and figure out which versions of stuff you want. The ultimate goal is basically to say, make this a lot easier, right? Have your binding, your wrapper in the Android Studio project, link it to your binding project in Xamarin, and then be able to just build and get like a NuGet package out that has everything that you need in it. So that's one of the end goals. For now, I mean, this plugin really definitely helps make things a bit easier. Yeah, that's all there is to it. All right, so that was a lot. I think we've got a little bit of time left to just kind of wrap things up. Yeah, so the slim binding approach, like I said, that's what I kind of want to see. We'll do more in the future to look at, like, for instance, if we go back to the iOS stuff, all of this stuff can reasonably be automated, right? If you pass me an Xcode project, what I'm going to try and build something to do kind of similar for that. So hopefully the pattern kind of sticks. I'd love to have feedback and see what people think of the pattern. I think it's a really interesting use. Yeah. So I guess with that, we've probably got maybe 15 minutes left or so. If there's any questions at all, I'm going to watch out and see if I can flip over to the other chat here on the stage. Oh, yeah, somebody liked the pirate R pun. Thank you, Sweekie. Any other questions? I know there's a lot to go through, and bindings are a tricky subject, but they don't have to be that bad, right? It can be not a terrible process, especially if you take this approach. All right, we got fans of slim bindings here. Excellent. We'll close up all the things, show some maps. Well, thank you everyone for coming out. If there's no more questions, it was fun to share with everyone and be a part of the conference, and something I'm hoping to get a little bit back into more now. Oh, Kotlin. Okay, one quick question with Kotlin at least. Yeah, so Kotlin, the interesting thing is Kotlin is really just it compiles down to bytecode just like Java. So you can actually use a Kotlin AAR jar file, and we can bind that today just exactly the same way. So if you're more comfortable writing code in Kotlin, please, by all means, go ahead and do that. What if you're using lambdas instead of overrides for their function? Well, and that's, part of what gets tricky with doing bindings, because not everything maps perfectly to a C# world. We are trying to do more about making the binding generator more intelligent. In the last 6 months or something, a lot of work was done around supporting Kotlinisms in bindings. So I'm not sure about Lambda specifically. I'd need to see like a specific example. Maybe you can pin me later. But again, if you take this approach, you can kind of get around it in some ways. Now, it's not always the approach that you can take either, right? If you're developing a big library and you want the entire API surface available, sometimes you just got to do it the old-fashioned way. So yeah. Yeah, issues doing Swift binding. Cool. All right. Yeah, Swift can be tricky, and check out binding tools for Swift because a lot of work is still going into that. Steve's working really hard on making that a reality. I was trying to follow the steps for Swift binding. Cannot see the generated interface header name option for the native framework build. Yeah, I'm not sure about Stripe specifically. They may have some kind of like preprocessor directive that you need to set or something to enable those annotations. That could be. Yeah, so that might be something to check out, is just kind of ask them, or pull down the library, maybe crack open the headers and just check and see if they're there or not for you. But again, with Stripe, you could do the same technique, right? You could kind of go ahead and make a slim binding around it. I would imagine that'd be an okay candidate too, even if the API is a little bit bigger that you want to end up with. All right. Well, thank you, everyone. I think we're about good here. Check in for the next session. Go take a break.